Hi everyone. Okay, so uh, we just go over the last time homework. So square root function. Okay, square root equations. Okay. All right. Now let's go over this one. Okay. But there's a rule there. Okay. Always when you have a sorry square root equations or radical equations. Okay. Always one side we need one more radical function over here, okay? Or other one is to the right, the other side. This is already isolated, okay? So this one is already isolated, that's fine. One is a check. Second one is square it, okay? You gotta make a square both sides. So this is squared and squared. That's the second step. Square root squared out. So 4x equals 6 squared is 36. After that, you can find the value of x. 9. Or in case just write check every time, okay? Check. X is 9. 4 times 9 is actually equals to 6. Yep, that is a 36 and 6. Alright? There equals. This is solution. Is okay? That's the rule. Second one is we need one radical sign. You want to keep this one, it's okay. You want to move this one, the other side. So negative, a little nice looking. Negative square root x equals to 11 minus 6. Right? 11 minus 6 is 5. That is isolate. After that, square root. I will square it, okay? This is squares and squares. Negative times negative positive. Square root x squared is x equals to the right hand side 5 squared is 25. Yes, x equals 25, but you can check it out. Always in the original, okay? Or equivalent. Doesn't matter. I'm going to use original. Put this number x in the original equations. 6 minus square root 25. It's okay. That is equals to 11. 6 minus 5 equals to 11. 1 is not 11. They are not true. It's okay? Yeah. That's not true means what? There are no solutions. You know why? I'm gonna move right this one the other side. Radical x. Okay, I'm gonna do this one. You got the equivalent over here, okay? Negative square root x equals to 5. That's right. Put this number times 1 times 1, okay? Times 1 times negative 1 times negative 1. So square root x equals negative 5. This is a principal square root. Principal square root always are positive, but this is negative. Positive cannot be negative. Okay, when you have right, this is a positive square root x equals to negative number, you don't have to solve it, just to accept no solutions. Okay, so this is what we don't need solve it this way. Just square root x is a negative number, no solution. Okay, because positive principal square root is positive, it can be negative equal. Okay, maybe this is a good for us. Okay, to save time. Check it out over here. Okay, one radical sign, we're gonna keep this one, okay? So isolate square root 4x minus 3 and minus 5, or the other one to the, okay, the other side. So that is equals to 5. But this is negative 5, no solutions. That's right. Square root, principal square root cannot be negative number. But this is a positive 5, it's okay. Alright, the next step is square it. Okay, you need to square the both sides. When you make a square left hand side, that's going to be 4x minus 3. Right hand side, 5 squared is 25. Okay, now solve. So 4x plus 3 equals to 28. And divided by 4, x equals 7. But we can check it out. When x equals 7, put this number in original or equivalent. Here is okay. So I'm going to original, okay? 5 plus x equals 7, 28 minus 3, is this equals to 10? Yes, it is. 5, 28 minus 3 is what? Square root 25, that is equals to 10. Okay, check it out. 5 plus 5 equals to 10. That's correct, right? So this is the solutions. Alright? Okay, number 4, we still have one radical with some constant. We're gonna only keep this one in our left hand side, or the other one will move to the right. So when you solve this way, 3x minus 2, this is positive, right? That's a principal square root, cannot be negative. Minus 5 minus 5. Oops. 3 minus 5 is negative 2. It can be for any value of x, because what? Inside the number always positive. With this number is negative, that is undefined. That is imaginary. Okay, it should be positive. Inside the positive, square root positive number, always positive. It's okay. Alright. But this number is negative. Okay, positive cannot be negative. It's okay. So there is no value of x which makes it positive equals to negative. Impossible. In this case, just what? Say no solution. Okay. The number 5 is a little different. Yeah, it's isolated already. Okay. One radical functions in our left, or other one is the right. That's fine. This is isolated already. Second one just square it. Okay, now let me square it. But this one is what? If this negative, no solution. Positive, there will be solutions, but it depends on the value of x. That's right. So we can continue anyway, because there is some restriction for the value of x. Okay, the value of x should be less than or equals to 5, isn't it? Maybe you can, okay, a little guess about the solutions. To have a solutions, x minus 4, this number, it 5, okay? So 5 minus 6 should be greater than or equal 0, right? Then we can continue. This is a positive, this is a positive. So from here we can say x is a less than 5, okay? Maybe you can, okay, guess, right? Yeah, the solution should be x is less than or equals to 5, okay? X equals less than or equals to 5. But it doesn't matter anyway, we're gonna check later, okay? But we guess we know that x should be less than equals to 5, alright? Okay, it's isolated already, but this one can be positive, negative, so we can continue square it. Left hand side, the square of radical is 15 plus x squared. The right hand side the square is how much? This is square is what? 5 squared is 25. 2 times x times 5 is negative 10x, and negative x squared, positive x squared. Okay, that's it. Now this is the quadratic, so one side should be 0, right? Okay. Oh, quadratic out. Now we're gonna isolate because that's now linear, okay? So you can make right minus 20. You're gonna keep the negative 10x on your right. It doesn't matter. So negative 25, negative 25. That is equals to negative 10 equals negative 10x. You can divide by negative 10 both sides. X equals 1, isn't it? Put this number x equals 1. Yeah, that's okay. X equals 1 is 5 minus 1 is positive. That might be a solution. Okay, check it out anyway. If x is 6, if you got the x is 6, 5 minus 6 is negative 1. it can be solution, right? But x equal 1, fine, because x minus 1 is a 4. This is a positive, this is also positive, right? Okay, anyway, check it out. Check. 15 plus 1 squared is 1 equals to 5 minus 1. Is this correct? Left hand side square root 16, that is equals to 4. Right hand side also 4, right? Yep, they are equal. So this is the solution. Number 6, we have a two radical equation there, okay? Two radicals in there. We're gonna take care of one radical at a time, okay? So the other one to the right. So this is isolated anyway. 5x minus 3 equals to square root x plus 17, okay? Always each one. Isolate. Anyway, squared 5x minus 3. When you square this one, x plus 17. Okay, minus x is what? 4x. Plus 3 is what? 20. When you divide by 4, x is 5. Check it out. Okay, check it out. Here, original, or here, they are equivalent. It doesn't matter. I'm going to use the original. Square root, we're going to check. When x is 5, 5 times 5 is 25, minus 3, minus x is 5, plus 17, that is equals to 0. This is what? Square root 22, and square root 22, that is true. Yes, that is the solution. Okay. This is already isolated. Okay, I'm not going to do everything, okay? This is already isolated because of one radical and the other one. So square it, okay? When you make a square, that is what? X squared minus 2x and plus 1 equals the square, that is what? 5x minus 9. It's okay. All right. This is one radical. The other one is what? Positive. It is negative, no solutions. But still, it depends on value of x. It can be positive, it can be negative. Okay, so we have to anyway continue to solve. Okay, minus 5x, I'm going to write here negative 5x, and plus 9 and plus 9 at the same time. This is all 0. Okay, so left hand side x squared minus 7x and plus 10 equals to 0. Because this is a quadratic, one side always 0, right? Why we need this one? We need a factor, okay, to use what? Zero product property. So this one can be factored. X minus 2, x minus 5 equals 0. The value of x is what? 2, and x is 5. So we need to check. Okay, we need to check. 2 minus 1 is a positive, 5 minus 1 is a positive. Maybe both numbers possible solutions. Anyway, check. When x is 2, put this number 2 in there. 2 minus 1 is a positive, that's fine. Put in there 5 times 2 is 10 minus 9. That is 1 equals 1. It's okay. That's the solutions. Now put this number 5 there. 5 minus 1, that is still positive, right? There may be possible answer too. So 5 minus 1 equals 5 times 5 is 25 minus 9. This is 4 equals square root 16. 4 equals 4, right? That's also solution set. Because when you check it out, okay, this is already positive for these two values of x. If, for example, if x is a negative, put this a negative. Negative 5, negative 1 is negative 6. This is why cannot be negative number. That is not solution, okay? This solution is called what? Extraneous solution. Okay? It's already separate, okay? So you can make a square, right? Okay, that's fine. I think you can do that. this is the one radical over here, the other one over here, okay? So we're gonna make a square, it's the same thing. Always one radical in one side, or you can use this one too. Plus 4 plus 4. You can use this one. This is one radical. It's okay too, okay? But I'm gonna take away 9x, one radical, this one. So make square both sides. Radical x, square root x squared is how much? X, okay? So 2 times 8 times radical is what? Negative 8 square root x, and negative 4 squared is what? 16 equals to square of 9x and 9x. Oh, we still have a radical in there, okay? So we're gonna keep the one radical. So I'm gonna keep the one radical to the left. Negative red x, okay? Or you can keep this as positive, it doesn't matter, okay? Or you can negative x, minus 16, minus 16, right? They're all out. So negative red x equals what is that? 9x minus x is what? 8x. And minus 16. When you have a negative sign, you better make it positive, okay? So positive how much? 8x equals to negative 8x plus 16, isn't it? Now we got only one radical number, but check it out. They're both is a multiple of 8, better divided by 8, okay? During the work, if it's possible to simplify, you need to simplify. So divided by 8, divided by 8, divided by 8. Now we got only one square root, x equals to negative x plus 2. Or 2 minus x is equal to. You can use, right? Or 2 minus x, it doesn't matter. Now we square it again. This is already what? Isolate. Square again. Radical x squared is x. Square this one, it doesn't matter. Negative x squared is a positive x squared. 2 times negative x is negative 4x, and 2 squared is 4, right? Now we got the radical quadratic equations. One side must be 0. So minus x, 0 equals x squared minus 5x and plus 4. I'm going to use this one, the original, okay? Now we need to factor this one, x minus 4 and x minus 1, that is 0. So we have two roots, x equal 4 and x equal 1. But we need to check always, okay? Always. The radical equation has what domain is restricted. That's why we need to check. 4 probably. Square root 4 minus 4 exactly equals what? 9 times 4. Check it out. Square root 4, there's a 2 minus 4 is a negative to left hand side. This is a positive, right? Impossible. 9 times 4 is what? 36. This is just 6. It can be equal. Negative, it cannot be positive. This is a good. So this is not solutions. This is an extraneous solution, okay? Extraneous means what? Fake. It's not real solutions. Now put this number 1 there. Square root 1 minus 4. This also what? Negative 3. This is a positive 3. Can be equal. This also is extraneous. This is no solution. Actually, this is what? No solution. Okay? Or maybe you can simplify this one. I'm gonna move this one the other side. So negative 4 equals to square root 9x minus square root x. It's okay. When you move this one, there's gonna be square root negative x, isn't it? Square root 9 is what? 3, right? 3 red x minus another red x, that is equals to negative 4. So let's simplify. These two is like terms, square root x. 3 over this one, 1 over this one, minus 2 over that one. Wow, this is a principal square root, always positive, but this is negative. At this time, you can make conclusion 2, no solutions. Well, divided by 2 continues this one. This one is accept always a positive number. Square root positive is always positive. This one already is a positive number. This side is a negative number. Positive cannot be equal to negative. From here, you can make conclusion, no solutions. Because some radical is a negative number, no solution. This is a principal square root. We have two roots, right? This is negative square root, positive square root. This positive square root is called what? Principal square root. Okay, maybe just a positive square root is okay too. Positive square root cannot be negative number, okay? So from here you can make conclusion, okay? No solution. That means what? You don't have to solve right long this way. It's okay, right? If you know the right this simple, okay concept, easily you can find no solution. It's okay. All right, that is number 12. Okay, application. I'm not gonna do this one. Okay, a little more on the imaginary number. After this, we're going into the other one. Okay. Okay. We're gonna check this one more times. Okay. So we have a variable in radical and outside also x. So one at a time. Okay. This is a +1 outside. This is an isolation. Okay. So we have a left hand side only one radical, or other one is to the right. After that, second step, what is that? Square it. Okay, you need to square it. Square of this one is x plus 1. Right hand side square is what? X squared plus 2x plus 1. Because this number can be positive or negative. If this is negative, no solutions. But it may be positive too. That's why we continue solve it. Okay. So we have a quadratic over here. So negative x, negative 1, negative x, negative 1. This side is 0. X squared plus x, 0. You can factor over here. Yes, you can factor. X is common out. Inside the parentheses what? X plus 1. So using 0 product property, x is 0 or x equals negative 1. Okay. Alright, now put this number in there. What happened? X equals 0. X equals 0 plus 1 is 1 minus 1, that is 0. True. 1 minus 1 is 0. Yeah, that is solutions. What about negative 1? Negative 1 plus 1. Minus 1 equals negative 1. This is also 0. Yes, negative 1 equals negative 1. This is also true. So both two numbers is the solutions. Okay. I think that's okay. Over here, right? That's the answer there. So you can have a little more practice, okay? Question number 2, okay? You can do this one. That's the answer key there. The next one is okay, graph of right the radical functions. Radical function. First one, that is parent radical function, okay? Radical functions. This is a function, okay? Function is always express y in terms of anything. 1y, okay? There will be only one value of y for any value of x. If we have a square, that is not a function, okay? If we have a 4 over here, y is what? 2 value, right? Okay, always function is what? Y equals. Okay, the radical function, this is a parent radical function, okay? We said what parent functions. That is the basic. We start. Parent function is y equals, I'm going to do this one. Radical x, this is parent functions. Okay, the graph over here. From here, one right to one up, right? And the pole, x is 4, y is 2, right? And when x is y is 2. When x is 9, y is 3, okay? This is the parent functions looked at this way. This is y equals square root x. This point is a starting point, okay? Because x, the minimum, x cannot be negative. The minimum number, x is 0. From here, okay, the graph will start. So 0 and 0, okay, when x equals 0, y equals 0, okay, so this is our starting point. Okay, the second one is if we have y equals square root negative x. Okay, what is the graph of this one? Negative x is what? The symmetry in the y-axis. X switch negative x. When you have x over here, xy, opposite over here, negative xy, isn't it? Y doesn't change. X changes by negative 2, positive x2, negative x. That is symmetry, okay, in the y-axis. Okay, so when you have a negative x, the graph is also starting point is 0 and 0, okay? The graph is to the left, 1 and 2, something like that, okay? The graph looks like this way. This is the graph of y equals square root of negative x. You gotta be careful, okay? Negative x. The next one is y equals negative outside x. Outside is what? Reflection over x-axis, okay? Outside the graph it looks like this. The other side, reflection over here, 1, and here over here, okay? This graph is y equals negative f of x, isn't it? Because this is f of x. This is a kind of a negative f of x. That's right. When you put the negative sign before the functions, it is what? Reflection over x-axis, okay? The other one is you put the negative sign. The other one over here also a same graph. This one is y equals negative x inside. That's the graph. Okay. Now I'm gonna move. They all have a starting point of 0 and 0. It's okay? Yeah, someone uses this as a vertex because that is what? End point. Okay? Or starting point is better. I'm gonna move this starting point is what? Somewhere over here. There is a translate. It's okay? If we have a y equals f of x graph. I'm gonna move this one. Okay? If this is just okay, center is 0 and 0, we're gonna move this way 0 and 0. We're gonna move this point is up here, h and k. That translate, okay? X move to the h is what is it? Instead of x, you're gonna replace this one, x minus h, isn't it? That's right. And the k is what is it? Plus k, that is outside. Okay? So I'm gonna move this 0 and 0, h and k. From 0 and 0, now we're gonna move this one h and k out there. So this is y equal radical x. Okay, we apply translation, one of the y transformation, okay? X instead of x, we replace with y, x minus h. The graph is what is the square root, x minus h. Outside plus k. Okay, so our starting point is what? H and k, isn't it? But we have our starting point is negative 1 and 2. This is what? Negative 1 and 2. But still, 1 right, 1 up means what? The value of a equals 1, right? That is, sometimes we use this one. A square root x minus h plus k. This is what? Scale factor. Okay? Scale factor. That is the graph is a little higher, a little lower. But if 1 right, 1 move to the right, 1 up, always a is 1. It is okay? So we are currently we're gonna handle only a is 1 only, okay? Okay, a is 1 only. Okay, this times we're just starting point negative 1 and 2, right? The graph is what? Move to the right, so we're gonna move this red x to here, right? Okay, starting point is what? Negative 1 and 2. Put this number h equals negative 1, k equals 2. So graph of this one is how much? X minus 1 and plus 2, right? Which is what? X plus 1 and plus 2. X plus 1 is move to the left by 1, okay? 1 unit left, 2 unit up, right? Okay. If you got over here, down over here. This is a negative 2 and 1, 2, 3, 4, 5, negative 5. What that means? 2 units left, 5 units down. So graph of this one is how much? From here, we're gonna make right here, right? So x minus 2, x plus 2, right? Move to the left, because what? X minus 2 is x plus 2. And outside you follow the graph, minus 5. It's okay? That's the equation of this lyrical graph. From here, we can find, okay, domain. Domain is what? How can you find the domain? Domain is what? Oh, I'm sorry. Okay, I'm sorry about that, okay? Yeah, I'm recording this one. Okay, I'm gonna post on YouTube. You can see the right video, okay? Alright, sorry about it. Oh my god. I didn't see that. Okay. Oh my god. Okay. A domain can be obtained inside the letter here, okay? This number inside the letter cannot have a negative number, okay? Always positive. From here we can find domain. So x is always greater than or equals to negative 2, okay? That's domain. The graph will start from negative 2 over here, right? And also this number is what is that? Range, right? The value of y. The value of y is always greater than or equal to this number. The range can be obtained right from these numbers. So y should be greater than or equals to negative 5, okay? But it depends on the graph. This graph is what? Positive, move to the right. That's why right side the domain, upper is range. Is it okay? Okay, the next one over here, we're gonna make a graph here. We are just starting point. This starting point is minus 1, right? This is a starting point. So starting point is the point, initial point or starting point. We are at negative 1 and 2, that's the starting point. Okay, so we're gonna make an approximate graph. Negative 1 over here, 2 over here. This is our starting point. This is a positive, x is a first, so graph looks like this way. It's okay? What is domain? Greater than or equals to negative 1. Domain is what? X is greater than equals to negative 1. Where is the range? Range is what? This is minimum. Range is y already greater than equals to 2. Okay? Okay, find domain. Now we got the negative sign there. Negative sign is what the graph is. Deflection across what? X-axis. This is negative, isn't it? That's right. Yeah, we start from here. So where is the starting point? Starting point is what? Negative 2. This is a starting point. Negative 2 and all together, right? Inside we need the negative sign, except negative part, the rest of them is x value. Outside you follow everything, okay? So negative starting point is negative 2 and negative 4 is our starting point. But graph outside the minus is going down. The graph looks like this. Where is negative 2 and negative 4? This is negative 2, this is negative 4. This is our starting point. This is going down this way. This is the graph of what? Negative square root x plus 2 and minus 4, right? What is domain? Domain is still always greater than equals to negative 2. That's right, because from here we can get the domain also. X is greater than equals to negative 2, isn't it? That is domain. What about range? This value. But this time this is a minus. This value is now maximum. Okay? Or other value of y less than or equals to negative 4, right? The range is what? Y is less than or equals to negative 4. That's the range. You gotta be careful, okay? The range and domain of a radical function is very important, okay? Yeah, domain is greater than or equals to -2. There's the answer there, okay? Because the graph looks like this one. -2 over here, -4 over here. This is our starting point. The graph is going down, right? Oops, where is it? Okay, so we are not going to this because you guys know this already. Oh, this one a bit different. Imaginary number, okay? So we're gonna learn what is imaginary number. So we have a sketch over here. Y equal x squared, okay? X squared is what? Vertex 0 and 0, isn't it? Because what? This is x minus 0 square and 0. This is a vertex 0 and 0, okay? Because 0 we don't have to write down, just what? X squared. Okay? The vertex is what? 0 and 0. Now consider x squared plus 1. X squared plus 1 is what? There's a translate, right? Move up 1 unit. Okay? 1 unit up. 1 unit up over here. We're gonna make this one. It's okay? Yeah, this is y equals x squared plus 1. But in this case, what is the x-intercept? You can solve this one. X squared equals to 0. Okay? Because what? To find the x-intercept, the y is 0, isn't it? Because we have an x-intercept over here. At these two x-intercept, y value always 0. Okay? So that's why let this value of y equal 0. Okay? Over here first. 0 equals x squared. The value of x equals 0, isn't it? Okay? But this is what 0 x equals. But 2 zeros actually repeated 0, right? Because the multiple is the 2, isn't it? That's fine. But if we have what? Y equals x squared plus 1. Y equals x squared plus 1. Is there any zeros? Zeros means what? X-intercept. Can you find x-intercept over here? They never have intersection over here, okay? Because the graph is the minimum value is 1. So take anyway 0. What is the value of x? X squared equals to -1. X squared cannot be -1, right? The square of any number is always positive. There's no number exists. Okay? There's no number exists means what? No x-intercept. That means what? No x-intercept. It's okay? No x-intercept. But we're gonna expand. Okay? We know that there's no x-intercept. Anyway, what is the value of x? It's imaginary. We're gonna define the value of x. Anyway, x equals how much? Plus minus square root -1, isn't it? Inside the radical cannot have a negative, but we assume that there will be something in there. Okay, so we're gonna find some imaginary number. Imaginary number is not real. So we define this number is I. So I equals to -1. This is imaginary. Okay? Yeah, that is imaginary. So imaginary root, there's no real root. That means that there's no real zeros, no x-intercept. Okay? Alright. So we defined square root -1 is I. That is defined imaginary number. But we know that x squared, when you make a square, that is -1, right? I is what the value of x. When you make I squared, still -1. What that means? When we have right imaginary number, maybe we can square it. Not anymore imaginary number. It's not real. Now this is real. Okay? It was before imaginary. But when you make a square, I squared equals to -1. This number, I squared, not I squared is real. Is okay? Which is what? -1. Okay? Okay. We have two worlds. Real world, imaginary world. Negative 1 equals I. When you square this I square move to the left in real world, that is equals to negative 1. That is not anymore imaginary, okay? Because we defined it this way, okay? All right. So we're gonna simplify. When you have an imaginary number inside, always we cannot live this way. Always we need to express it in I. Okay, that's our rule. This one is how much? I. Use it I instead of this number we replace with I. Okay. So you have a square root negative 9. So we're gonna express this one in terms of I. Okay. Take a look. Negative 9 is what? 9 times square root negative 1, isn't it? Okay, you can separate. But this is I. This is I red 9. Okay? But square root 9 is what? 3, isn't it? So I3, when you have real number, it's gonna be used like this one, 3I. Okay? Number first, I is second. Still this is imaginary. It's okay? So when you have a negative number, separate with a positive and negative number. Okay, so this is what is that? Separate 4 over 25 and square root negative 1. This is how much? 2 over 5. This is I. That is equals to 2 over 5I. Okay? Because this number is an imaginary number because with I. Number C over here. This one first. Square root 160, negative 162 is 162 times square root of negative 1. Also, we still have a 2 over here. This is I. Simplify 162. 162 is what? 81 times 2, right? 81 is what? 9. Square root 81 is what? 9. It's okay? So this is actually 9 red 2. So 2 times 9 red 2 is about 18 red 2. We still I there. But when you have a irrational over here, when you have irrational numbers, our mathematical rule put this number just before the irrational number, okay? Just before irrational number looks like this one. 18I red 2. Why? Because sometimes someone like this one, negative 2I inside or outside, a little bit confused. That's why you put this one before the irrational. Okay, that's our mathematical rule, okay? But this is also, it's okay too. 18 red 2 over here I. Okay, this is fine, but our mathematical rule we recommend to use this way. 18 I red 2. Okay. Complex number is a combination of real and imaginary. It's called complex numbers. This is the real part. This is the imaginary part. With I, because what this number imaginary, because what it has I, okay, all right. So this is real, the other one is all imaginary, okay. That's the combination of real and imaginary, okay. And the 7 is we said real part, and coefficient of I 2 is what imaginary part, okay. So we're going to express this one a plus bi form. This is what? Real and imaginary. Negative 36. Negative 36 times square root of negative 1. This is I. Square root 36 is 6. You can use 6i. That's it. We still have real part over here. Real number 4 plus imaginary number 6i. That is, we said a plus bi form. A plus bi form is the simplest complex number. Okay, this is the simplest form on complex. simplest form, complex. Okay. Now second one is this one first. This is a positive, negative 1 is outside, square root negative 1. This one is I. This one is 2 red 6, okay? 2 red 6 and I outside, we have 8 minus. But by our mathematical rule, this I move in front of what? Letter, okay? So 8 minus 2I red 6, okay? Okay, now operation of I. I1 is I, this is still imaginary. When you make I square, there is a negative 1, right? Our definition, x squared equals negative 1, right? This is I squared is negative 1. Our definitions, that's why this is always a negative 1. This is imaginary, but this is real now. I cube is right there. From here, times 1I. I cube is what is the I squared times I to the 1 by exponent operation, right? So I squared is negative 1, this is a negative I. Same thing, okay? You can reduce this one. So I cube number is still imaginary. This is still imaginary. I to the 4 is what? I squared times I squared, right? This is I squared times I squared. That is what? Negative 1 times negative 1. That is a positive 1. That is real. Okay? What about I to the 5th power? I to the 5th power is I to the 4 times I to the 1, isn't it? We know that I to the 4th power is always 1, right? This is always 1. But looks like I to the 1. This is the I. I to the 6th power, you still take up 2. I'll take up 4 over here. Because this is always 1, right? Always 1. So 1 times I square, because the I square is still negative 1, right? But this is real. I to the 7 equals to what? I to the 4 times I to the 3, right? 3 plus 4 is a 7. I to the 4 is always 1. So it equals to I cube. I cube is what? Negative I. I to the 8 is what? I to the 4 times I to the 4, right? This is 1 and 1 still 1. So what is this number? This number is a periodic. I square, I cube, I to the 4. This is I, this is negative 1, this is negative I, this is 1. The next one is I to the 5th power, I to the 7th, 6, I to the 7, I to the 8, I to the 9, I to the 10, I to the 11, I to the 12. Always this rule is equals to 1. What? If this number is a multiple of 4, okay? Multiple of 4, always the value of this one equals to 1. Okay? Maybe someone knew this one. Exponent number. Exponent number divided by 4. When you divide it by 4, that is 1. Okay? Remainder, okay, when you divide it by 4 is what? Remainder is 0, right? When you divide it by 4, remainder is 0. Remainder is 0, the value of imagined number is always 1. When you divide it by 4, remainder is 1 over here. This is what? Remainder is 1 means 1i, right? Belongs to over here. This is remainder is 1. This one is the remainder is 2, always negative 1. If you got the remainder is 3, always negative I. Remainder is 0, always equals to 1. Okay, you can use this formula too. Or this exponent is a multiple of 4, always 1. You can use this one too. For examples, I to the negative 98. I'm going to use a remainder. We have exponent 98. We can simplify. 98 divided by 4 is what? 2, 4, 8. And 18 divided by 4 is what? 16 and 2. Remainder is 2. When you got remainder 2, this is exactly equals to I square, okay? Because what? Remainder is 2 is I square, isn't it? This is a negative 1. It's okay? When you remainder 1, the value of this imaginary always negative 1. Or you can use I to the up to 96. This one equals to what? I to the 96 and times I to the square. Because we know that 96 is what? Multiple of 4, right? Because what? I to the 4 times 24, isn't it? This is 1. 1 to the 24 still 1. So this is already 1. So I squared is negative 1. You can solve it this way too. Okay? Now we can have some practice there. Already that is a periodic number, okay? Alright, first one. We're going to find the simplest form over here. I to the 13. 13 divided by 4 is what? Remainder is 1, right? That is equals to I. Yes. Or up to I to 12. That is 1. We still have one more I. That is I equals to I. I16 is 1. We still have I square, right? I square is negative 1. I'm going to use I square. Okay, this is negative 1. I to the 30 is what? I to the what? 28, that is 1, isn't it? Because this number is what? Multiple 4. Or you can divide it by 4. 28 divided by 4. 31 divided by 4. 31 divided by 4 equals what? 28. Remainder is 3. Remainder 3 is what? I cube, isn't it? Same numbers, I cube. This remainder is 2. When you divide it by 2, that's why 2, 3, and plus 1 equals 0, okay? This one divided by 4, remainder is 1. Okay, put up here. After that, you can simplify. I to the 1 is I squared is negative 1. This one is negative I, and plus n equals 0, okay? So I minus I is 0. So n equals to how much? 1, right? Over here, I'm going to use what? Divide. 25 divided by 4 is what? Remainder is 1, right? So this equals to remainder is 1. I to the 1 is I. That's it. 55 divided by 4. 55 divided by 4 is what is that? 1, 4, 15, 3, 12. Remainder is 3. That means what? Equals to I cube. I cube, you know, that negative I, right? Simplify. I16, 16 divided by 4. Remainder 0. Remainder is I to 0. I to 0 equals to 1, isn't it? 34 is what? When you divide by 4, remainder is 2. That is exactly equals to I squared. That is equals to negative 1. Okay. And this is a negative 1. We already got I squared is a negative 1. I cube is a negative I. So negative 2. This is negative I. 3 times negative I is a negative 3I. You can leave this one. They are not like them. This is real. This is imaginary. You have to leave it this way. Negative 2 minus 3I, okay? A little more practice on higher number there. 100 divided by 4 is what? 25. I to 0, that is 1. Multiple 4, right? 101 is what? When you divide by 4, remainder is 1. I to the 1, I. 102 divided by 4 is what? Remainder is 2, right? I squared. But this I squared is negative 1, isn't it? That is a real number, not imaginary anymore. So 1 minus 1 is out. This is simplified in y. Okay. Number D. I cube how much? Negative I. I16 is what? 16 divided by 4 is what? 0. That is 1. That equals negative I. Okay. Alright, number 4, 300 and negative 1. This is I. So this is actually equals to what? Square root 300 I. I'm separate anyway. What is this one? 10 times, 100 times 3, right? Square root 100 is 10, isn't it? This is a 10, red 3, I. But this is irrational number. We're going to put the I between these two numbers. 10, I, red 3. Is it okay? So we already 10 red 3 over here. Okay, simplify this one. Now you know that, right? The minus 1, this minus means I. That it looks like 18I, I 32. You can go directly now. 18 is what? 3 red 2, right? 9 times 2 is what? The square root is 3I, 3I red 2. This one 32 is what? 4, 16 times 2, right? 4 out, red 2. But this is what? Like terms. Okay? So you can add 1. 3I minus 4I is how much? 3 minus 4 is what? Negative. Okay? So negative I, red 2 is the answer. Okay? Okay, we're going to jump. I think that's okay. I think this is okay. Okay, we can jump over here, okay? That is not hard. Okay, we're gonna do this one, conjugate. Conjugate means what? Real is the same, but imaginary is always opposite sign. If we have a 3 plus I, its a conjugate should be what? 3 plus 2I. Okay, this pairs we say conjugate pair, okay? If this is one of the root, always imagine the root is what? Pairs. If this is one of the root, this is the other root, okay? The other complex root, always. Okay, because when you have a quadratic formula, x equal how much? Negative b plus or minus square root, okay, b squared minus 4 times ac over 2a, isn't it? This is the quadratic solutions. If this number is negative, I'm going to use some number of it, negative 10 plus or minus 100 over 2. What is the root? How it looks like this one? Root of this one always what? This is how much? 100 times red I. This is I. This is 10I, isn't it? 10I. So root always what? Negative 10 plus minus 10I divided by 2. When you simplify, negative 5 plus minus 5I. Always the root is pairs. This is root, negative 5 plus 5I. The other root should be what? Negative 5 minus 5I. This we said conjugate pairs. Okay? So complex root always right in pair of conjugate pairs. Okay, this one is okay, right? I'm going to try this one first. 2xi times I is what? 2xi squared, and 2 times 4 is what? 4xi times I squared is I cubed. I squared, we know that is a negative 1, negative 2x. I cubed is a negative I, right? So negative 4x times negative I is a positive 4xi. It's okay? I think that's okay. So we're not gonna do this one, okay? We can go into the next chapter, okay? All other range, okay? So this is a new chapter over here. When you see that over here, that is the content of Unit 5. Okay, the first one, completing the square. You learned this one in Algebra 1, okay? And the quadratic formula, you learned this one already. Solving quadratic equations. Okay, so we're gonna have some practice go over section over here, right? After that, this is our main topic today, locus of a parabola, okay? So we're gonna have some go over something, okay? Or a text. We're gonna solve this one. But this is already what? Complete the square. Left hand side is where the perfect square. This is a constant. This is already what? Completing square already. Right? This is already complete square already. But to solve this one, you don't have to expand this one. Keep continue from here. When you have a completed squares, square root. After that, when you have a completed square, after that you need what? Square root both sides. Is okay? Square root. Square root over here, what you got? X minus 3, left hand side. Right hand side always what? Plus minus, okay? When you need the plus minus square root 25, which is equals to what? Plus minus 5. Isn't that is complete the square? The next step. How can you find x? You can plus 3. Always 3 is what? Before the numbers. So x is exactly equals to 3 plus minus 5. But these two numbers is a constant, like terms you need to simplify, okay? One is what? 3 plus 5. The other one is 3 minus 5. 3 plus 5 is 8. 3 minus 5 is negative 2, right? Solution is what? X equals 8 or negative 2 is the solution using complete the square. It's already complete the square over here. But now we have a general form over here. That's a standard form. That is not complete the square form right now. How can you find the complete square? The step 1, variable terms, constant terms separate. I'm going to use step 1. I'm going to use step 1. Variable terms, b terms, and constant terms isolate. Okay? How? X squared minus 2x. Constant term, move the other side, 23. That's it. That's the step 1. After that, to find the perfect square from here, we need some number over here. You guys know this one, okay? How can you find these numbers? Negative 12, the middle term, n divided by 2, n square, give us what? 36 is the numbers. When you have 36, you can add 36 to the right hand side too, because still they are equivalent. These three terms is called what? Perfect square, trinomial. Perfect square trinomial can be replaced with what? Perfect squares. This one, three terms can be replaced with what? X minus half of this number always inside, okay? Half of this number, negative 6 squares. This one is actually replaced with this way. Okay? Exactly equals. That's why we said this is a perfect square, but there is a three terms are there, trinomial. But actually this is a perfect square term over here. But right hand side, how much? 23 plus 36 equals to 59. This we said completing the square. This process we said completing the square. Using, if you find by completing the square, you can make right square root. Both square root, both sides right there. First one is x minus 2. Do not use what plus or minus, okay? I'm going to put plus or minus to the second term over here, okay? When you make a square root, always plus or minus over here. You don't have to use over here, okay? Alright. But it's the same things, but most complicated. So over here, plus minus square root 59. That's right. After that, to find the value of x, you can plus 6 both sides. But plus 6 will always be before plus minus, okay? X equals what? 6 plus minus square root 59. That's the solutions. You can separate, but you don't have to. Just you can leave it plus minus, okay, too. Or you can use this one. 6 plus square root 9. 6 minus square root 59. You can separate, but this is better, okay? Yeah, that's just steps that complete the square, okay? You can read this one. Remember, okay? There are just steps there. The next one, you one more try this one. Simply is the radical form. We're going to find my solutions using complete the square. I'm going to use a complete the square, okay? Because this is not factorable. 23 and 1. 24, right? It is not negative 12. That is not factorable. That's why we use quadratic formula or complete the squares. We have two different ways. You can use quadratic formula. This simplest one. Because if This is not factorable because that is not factorable. So we have to use what quadratic formula or completing the square. Okay, completing the square. We have two different ways there. I'm going to use both. Quadratic formula is what? Formula, just substitute in the formula. X equals what is that? Negative b plus minus square root b squared minus 4 times ac over 2a. That is the quadratic formula. Because over here, a is 1 coefficient of x squared, b is what? Middle term coefficient of negative 12, c is what? 23. Or put this number in the equations. It's very simple, right? b is negative 12, negative 12 is positive 12 plus minus. b squared, negative 12 squared is 144. And minus 4 times a is 1 and c is 23. Over 2 times a is 1 is going to be 2. So 12 plus minus. Inside is how much? 144 minus 4 times 20 is 92, right? 144 minus 92 is 52, right? 52 square root 52. This is how much? 2 red 13, isn't it? So inside the number, now this, I'm going to 2 red 13 over 2. So divided by 2 both sides. So it is 6 plus minus red 13. That's the answer. But complete the square. This is the quadratic method 1. This is completing the square. Variable terms, constant terms separate. Okay, this is isolated already. Now we're gonna find perfect square trinomial. Why we need this perfect square trinomial? We need what? Perfect squares. So we need these numbers. This number is how much? Negative 12 divided by 2 is negative 6 squared, 36. We're gonna add 36. So from these three trinomial can be replaced with a square, right? Inside the number almost x minus half of this was just 6. That's it. Right hand side 36 minus 23 is what? 13, isn't it? This is, we said, completing the squares. After that, square root, okay? X minus 6, the next is already plus minus 13. So plus 6 both sides, x equals to 6 plus or minus square root 13. It's the same solutions. It's okay. Now we're gonna keep going. The next one. Okay, the complete square is okay. Because if right does nothing right specified, you can use right quadratic. Okay, first one you can try factor, okay, when you have a quadratic. Second one is if not factorable, okay, you have to choose right quadratic formula and complete the square, okay. This is what 4x squared. This move to the left is what positive 4x. Move to the right, the minus 5 is what minus 4 equals 0. When you divide by 4, always x squared plus x minus 1 equals 0. This is not factorable. Okay, in this case, you can use a quadratic formula or completing the square. Okay, so I'm gonna find another one over here. Complete square coefficient is not equals to 1. But this is coefficient equals to 1. It's okay, right? Always you gotta make coefficient equals to 1. I'm gonna find some other examples over here. This is E1. Okay, complete the square, right? You can use this one. Take this one. X squared minus 8x equals to 7. Isolate. To make perfect square trinomial, we need some numbers over there. Add some numbers to the right also. Negative 8 divided by 2 is a negative 4, and squared is 16. You can add to 16. This is, we said, perfect square trinomial. But this is replaced with the square numbers, okay? Already half of this number inside, negative 4, that is equals to 23. That's it, okay? That's it, complete the square. I'm gonna not do this one. Now we have this one. Okay? I'm gonna solve this one and complete the squares. Complete the square is variable terms in the same side. It's gonna look like this one. 1 over 2 x squared minus 6x, constant terms the other side. But you gotta be careful. When you use complete the square, coefficient x squared always should be 1. Coefficient coefficient of x squared must be equals to 1. This is 1/2. We cannot use complete the square, okay? So to make it 1 times 2 to the order terms times 2. So 1/2 times 2 is what x squared. Negative 6 times 2 is what 12x equals to negative times 7 times 2 is what negative 14. This is our starting point. Okay, now from here we can find the complete the squares. We're gonna add some numbers to find what perfect square trinomial. Negative 12 divided by 2n square, right? Negative 6 squared 36. You can add 36 to right hand side. But this is trinomial replaced with a perfect square. Half of this number, negative 6 squared equals to 36 minus 14 is about 22, right? Now, square root x minus 6 equals to plus minus square root 22, isn't it? Now plus 6 both sides, x equals what? Plus 6 over here, 6 plus minus square root 22. That is your solution. Okay? Don't forget, when you use a complete the square, coefficient of x squared should be equals to 1, okay? They are all over. Oh, this one is not equals to 1. Okay? And also all the term is 1 multiple 2. Anyway, you need divided by 2 to make a 1, okay? So this is x squared minus 4x and minus 8 equals 0. You start from here, okay? So x squared minus 4x equals to 8. Okay, isolate. Variable terms, constant term is isolate. The next step is what is that? Perfect square trinomial. We need to write perfect square trinomial. We're going to add some numbers over here. What is this number? Middle number divided by 2 and square always, okay? That is a 4. We're going to add a 4 with it. This is, you said, perfect square trinomial. Replace with what? Squares, okay? So what is inside? X minus half of this one is negative 2 square equals to 12. Now square root. X minus 2 always what? Plus minus 12. It's okay? So you can add 2 both sides. So x equals finally 2 plus minus 2 red 3 plus minus 2 red 3. Okay? That's the solution set. But this is okay. This is a 1, right? It doesn't matter. It can be fraction. Okay? Don't multiply by 4, right? If you multiply by, this is already 4, okay? Always what? Coefficient of x squared should be equals to 1. It's already 1 there. That's right. Don't change this one. So what is the next number? You're going to add some number, right? Perfect square trinomial. What is that? How to get these numbers? Negative 5. Second number divided by square. And square, okay? How much? 25 over 4, isn't it? You can add the 25 over 4. You can add the 25 over 4 there. But this is a perfect square trinomial. Okay? Can be replaced with a perfect square. Always what? Half of this number is 5 over 2 squared. This is exactly what? Equivalent. X squared minus 5x, okay? Plus 25 over 4 is exactly equal to this one always, okay? The right hand side, 3 over 4 plus 25 over 4. 28 over 4, that is 7. After that, you can square root. So x minus 5 over 2. Don't plus minus, don't put over here, okay? Plus minus second, only one number is enough, okay? So second number I'm going to put over here. Plus minus square root 7. Now plus 5 over 2. Plus 5 over 2, both sides. You got the final answer. 5 over 2 plus minus the square root 7. That is your solution, okay? This is okay, you can do that, right? Perfect square trinomial. How can you back to perfect trinomial? Middle number divided by 2 and square, okay? Negative 1 over 8 and square equals what? Negative 1 over 64? No, positive 1 over 64, okay? That is the value of k to make a perfect square trinomial. Move on over here. I'm gonna find out that all coefficient is x. This is, we did it. This also, you can divide by 2. This is also divisible by 3. Which one is not divisible by 3? Okay, when you use it, okay, complete the square, always what? This one is 1, okay? But this is all the terms is divisible by 3. You can switch this one. X squared is what? 8x equals to 4, isn't it? That is what? Variable terms, constant terms, isolate. From here, you can try complete the square, okay? But this number is how much? 8 divided by 2 squared is 16. You can add a 16 to the right side. This is what squared. Half of this number. X plus 4 squared equals to 20. Square root. X plus 4 equals what? Plus minus 2 raised to 5. It's okay. After that, you can subtract negative 4 there. So x equals to negative 4 plus minus 2 raised to 5. Okay. So remember, to solve quadratic equation, first one, if factorable, use factor. If factorable. If not, use quadratic formula. That's the formula. Third one, complete the square, okay? Completing the square. Nothing else, okay? Only 3 methods available, okay? Okay, this is a bit near. Okay, they are divisible by 3. Okay, that's fine. Also, this is divisible by 3. This is also divisible by 6. If you want to use a complete square, you can divide it by 6. Okay, they are all correct. This is not. This is 5 is not divisible by 2. Okay, 6 is divisible by 2, but to use complete the square, coefficient of x should be equals to 1, okay? Anyway, we need to divide by 2. Okay, so x squared minus 5 over 2x, separate 3 over here, okay? Isolate. And variable terms and constant terms, isolate. But we apply complete the square. What number do we need over here? It's an easy one. Negative 5 over 2 divided by 2 is about 5 over 4. And square is how much? Positive 25 over 16, right? You can add over here 25 over 16. Okay? This is what perfect square trinomial. This replaced with what? Squared numbers. X minus half of this one is how much? Negative 5 over 4. Half of this one, 5 over 2 times what? Divided by 2, right? 5 over 4. Square right hand side how much? 3 plus 25 over 6. 3 is what? 48 over 16. It's okay? Alright. 48 times plus 25 is what? 73. 73 over 16. That's it. Now square root x minus 5 over 4 equals what? Plus or minus square root 73 over 16. But 16 is about 4 square, right? Looks like this one. 73 over 4, isn't it? Now finally we can add 5 over 4, right? Because we're going to find the value of x over here. X equals 5 over 4 plus minus square root 73 over 4. That's the answer, okay? This is the same thing, number 13, okay? To apply complete the square, we need a coefficient is 1 over x squared divided by 5. So x squared we start. But still, it doesn't matter. Second term, the constant term, it can be fraction, okay? This is a negative 4, 0. Okay, so this is what? Isolate. Variable terms. Variable terms, 4 over 5x, and the constant terms, isolate. Now we need to find what? Perfect square trinomial. what is this number? Half over this one, how much? 4 over 10, right? Or 2 over 5 is half of this one. Times 1 half is what? 2 over 5. That is half of this one, and make square how much? 25 or 4 over 25. That's it. Already positive. So you add what? Same number, 4 over 25. This all three is what? Perfect square trinomial. Replace with this one. X minus half of this one still 2 over 5 square, okay? This is how much? 100 over 25 plus 4 over 25. 25 over 104. Now square root. X over 25 is a plus minus always. You need a plus minus square root 104 over square root 25 is a 5. You can leave it separate. It's okay? So plus 2 over 5 both sides. X equals how much? 2 over 5 plus minus square root 104 over 5. That's the answer. 104 over 5. This is what? 4 times 26. It's okay? This is still just simplified. 2 red 26, okay? This one exactly equals to 2 red 26. That's the answer, okay? You know the quadratic formula, okay? Maybe you can prove this one, quadratic formula. Quadratic formula is from completing the square. Okay, maybe I'm gonna prove this one, okay? After that, there's been no questions, okay. How we prove a quadratic formula? There's a process over there. I'm not gonna do this one, that is so complicated. So if you have the ax equals plus b, x plus c equals 0. That is what? Standard form of quadratic, okay? So I'm gonna apply this one, complete the square. What is the complete the square? Because coefficient a over here, we need a coefficient of 1, right? So divided by a, divided by a, divided by a. So we got to x squared plus b over a x and plus c over a. C over a is a constant separate. C over a minus. Okay, now we're gonna find what? Perfect square trinomial. Trinomial, this one is how much? Half of this one is b over 2a but square, right? That is equals to what? B squared over 4a squared. So you're going to add the b squared over 4a squared both sides. This is about perfect square trinomial. Inside is how much? It's same as before, just the letter. Plus half of this one is how much? b over 2a and square. But this one simplify 4a squared. This is a 4a squared. This is a 4a, right? So b squared, common denominator same thing. B squared minus 4 times ac. Now square root x plus b over 2a is equals to how much? Plus minus square root b squared minus 4 times ac over square root 4a squared how much? 2a, isn't it? It's okay? But sometimes this one is what? Absolute value. We still have a plus or minus. It doesn't matter. Just what 2a is okay too. That's why we don't need, right? Absolute value 2a. Because we have a plus minus. So after that, you minus b over 2a minus b over 2a, okay? So value of x equals to how much? Common denominator 2a, 2a, so I'm going to put them together. Numerator, what is that? Negative b plus minus square root b squared minus 4 times ac. This is a quadratic formula, okay? Actually, quadratic formula from here, okay? Complete the square, okay? This is looks like quadratic formula, okay? This is okay. Okay, so we cannot go into okay, we did write the imaginary root already, okay? But next time we're going into locus of a parabola, okay? So this one, this parabola has a focus and directrix, okay? After this, because today we are going to go into trigonometry, trig functions, but this is important. Okay, that's why we're going to do this one next time, a little around 30 minutes after going into trigonometry. Okay, so you finish up to here. Okay, that's all today. Okay, so I'll show next time. If you guys have any questions, you let me know. Okay, I'm gonna post this video on YouTube. Okay, you take a look. Okay, because the first beginning. Okay, you didn't listen. Okay, all right. So I forgot to unmute. Okay, sorry about that. And I'm gonna put this one a lot of weight in your YouTube. Okay, I'm gonna send out. Okay, thank you so much. I'll see you next time. Thank you.